we are given data on bond energies. This problem illustrates the application of thermodynamics in organic reactions. We are given three reactions. In each case, we find a few bonds are broken and a few bonds are formed. In the first case, we have a carbon-hydrogen bond getting broken, a Br-Br bond being broken, and the bonds produced are C bond Br and H bond Br. In the second case, we are breaking a carbon-hydrogen bond, iodine-iodine bond, and forming a carbon-iodine bond and a hydrogen-iodine bond. In the third reaction, we are breaking a carbon-carbon double bond and a hydrogen-hydrogen bond, and we are producing a carbon-carbon single bond and two carbon-hydrogen single bonds. We are given the relevant data on bond energies. In general, if you have to calculate delta H for a reaction, it is given by the sum of the energy required to break the bond minus the sum of the energy released in bond formed. That is sigma bond energy broken minus sigma bond energy formed. So in the first case, we are adding the carbon-hydrogen bond energy and bromine-bromine bond energy, and from this we subtract carbon-bromine bond energy and hydrogen-bromine bond energy. The result is minus 36 kilojoule. Similarly, in the second case, we get plus 67 kilojoules. And for the last case, which is an example of an addition reaction, we have minus 163 kilojoules. Note that we have used 2 into 410. The bond energy of hydrogen carbon is only 410, but we are multiplying by 2 and adding with carbon-carbon bond energy. This is because we are producing 2 carbon-hydrogen bonds, and therefore the energy release will be double the bond energy of carbon-hydrogen. If you note the signs, in reaction 1 and reaction 3, we have negative signs. Both are examples of exothermic reactions. The second reaction is endothermic. So this illustrates how to predict the feasibility of a reaction using delta H for the reaction. If the sign is positive, the reaction is not spontaneous. So iodination of methane is not a feasible process if we try direct iodination of methane. Bromination is possible by directly treating bromine with methane. We also note the addition of hydrogen to ethylene is very strongly exothermic. It is because a pi bond is weak. We are replacing a pi bond by sigma bond. We are breaking a weaker bond and producing strong sigma bonds. So any addition reaction is spontaneous.